This is Walter. Walter is a robot that likes to travel the world, gathering data and samples as he explores. Today, he is scanning parts of the Himalayas, a mountain range that contains Everest, the highest mountain on planet Earth. Let's let Walter roam, and we can meet him after he's done. Walter uploads his data and gathers his samples when he returns. Today, we're going to borrow some of his results and use them to learn. Specifically, we're going to be learning about the addition, subtraction, multiplication and division of decimal numbers. The first thing we're going to learn is how to add decimal values together. To stay organised, Walter likes to split up the places he scans into zones. In the first zone of the Himalayas that he scanned, the air pressure was 45.09 kilopascals, which is the same as 0.445 atm. In zone 2, his readings were 34.17 and 0.337. Let's first practice with our two smaller decimals, 0.445 plus 0.337. The method for the addition of decimals is to stack them on top of one another and then add the columns, working from right to left. So here we have our decimals stacked, and now working from the right, 7 plus 5 equals 12, so we leave 2 at the bottom and carry the 1 onto our next column. Now we have 3 plus 4 giving 7, plus the 1 that we carried, so 8, and we have nothing to carry, so we leave this at the bottom too. 3 plus 4 is 7, it goes to the bottom, and 0 plus 0 is still 0. And we've solved our problem and learnt the method for the addition of decimals. Let's try again with our larger numbers, 45.09 plus 34.17. We stack our decimals and work from right to left. 7 plus 9, 16, so we carry the 1 and put our 6 at the bottom. 0 plus 1 plus the 1 that we carried, 2. And then 5 plus 4 is 9, so 9 at the bottom. Finishing with an easy 4 plus 3 equaling 7 and giving us our answer 79.26. One final example. In a third zone, the air pressure was measured to be 33.739. We stack and work from right to left, but you also need to notice that we had two numbers to 2 decimal places before, but our new number is to 3 decimal places. To help avoid mistakes, make the two numbers with 2 decimals have 3 decimals by placing a 0 at the end of them. Now we solve as normal. 9 plus 0 is 9, so 9 at the bottom. 3 plus 9 equals 12, plus 7 equals 19, 9 down, carry the 1. 7 plus 0 plus 1 equals 8, plus the 1 we carried, 9. 3 plus 5 is 8. Plus 4 is 12, so 2 down, carry the 1. 3 plus 4 is 7, plus 3 and the 1 that we carried, giving us 10, then 11. So 1 down and carry the 1. And then because we have no more numbers, we can put this on our bottom row. Otherwise, it would essentially be 0 plus 0 plus 0 plus 1. So our answer is 112.999, and we have learnt how to add as many decimals as we want now. And we've also learnt what to do if our decimals have a different number of decimal points. As we move on to learn about subtraction, we're going to be looking at data involving Walter's altitudes or heights of flights as he was exploring the Himalayas. So Zone 1 had an average altitude of 6.24 kilometers to 2 decimal places, and Zone 2 an average of 8.83 to 2 decimal places, making Zone 2 higher. Subtracting one from the other lets us find the difference in height between the two zones. 8.83 minus 6.24. We stack just like before and work from right to left, subtracting this time instead. 3 minus 4 gives us a negative number, minus 1, and we do not want this. So we're going to borrow our 3 some help, and we're going to do this by borrowing 1 from the column to the left, making our 8 become a 7, and letting us make our 3 become a 13. Now 13 minus 4 is 9, and we put 9 in our answer row. 7 minus 2 is 5, so 5 at the bottom. 8 minus 6 is 2, and our answer is 2.59. And we've learned our method for subtraction and what to do as well when we find negative numbers. As I mentioned, these measurements in kilometers were rounded by Walter, so let's see the full measurements he took in meters and use them to practice subtraction with larger numbers. Just as before, right to left, and we need to give ourselves the same number of decimal places to work with, so we insert a 0 on the end of our first number. 0 minus 1 would give us minus 1, so we borrow again. Now 10 minus 1 is 9, and that goes to the bottom. In our next column, 2 minus 9 gives us a negative number, so again we borrow from the left. This turns our 4 into a 3, and allows us to make 2 become 12. And now our sum is 12 minus 9, which equals 3, so 3 goes down the bottom. And then next we have 3 minus 1, which equals 2. And in our next column, we would have 0 minus 3, which would give us negative 3, so we need to borrow again. Now we have 10 minus 3 is 7. And in our next column, 2 minus 4, so we have to borrow. This gives us 12 minus 4, leaving us with 8, so 8 goes to the bottom, and we move to the next column. 7 minus 2 is 5. And finally, 8 minus 6 is 2. Now, come and have a look at this little problem with me, as there is a trap in it. So if we start right to left as normal, we have 0 minus 4 as our first problem, which is fine, because we would just borrow as normal. But there is the trap. When we're trying to borrow from a 0 in our next column, which we can't do. So in circumstances like this, we double borrow. So take 1 from your 0 and leave it as a 9. And then from the column next to it, we perform our double borrow and reduce our 5 to become a 4. And then we can just continue as usual. Back to the first column, 10 minus 4 is 6, that goes at the bottom. Next, 9 minus 8 is 1. Then we hit a problem with 4 minus 7, so we borrow from the 3. 14 minus 7 is 7. And finally in our last column, 2 minus 1 is 1. I've taken some of Walter's data on wind speed, and we're going to use it to learn about division and decimals. When it comes to the division of decimals, one approach is to start by making the numbers easier to work with. But before we do that, I want to show you what it is that we're doing here to make them easier to work with, and why it's the same as if we just left them alone. So 2 divided by 0.5. Instead of working with 0.5 as our divisor and leaving it as a decimal, I'm going to make it a whole number by multiplying it by 10. 0.5 multiplied by 10 is 5. And now if we multiply the 2 by the 10 as well, we get 20. And this gives us an easier problem to solve, because 20 divided by 5 is 4. And that's exactly the same as 2 divided by 0.5. You may have just been able to do 2 divided by 0.5, and that's fine. But as the questions get harder and harder, it makes this technique more and more useful. In our first example, let's make our divisor 0.4 become a whole number. 0.4 multiplied by 10 gives us 4, and 12 multiplied by 10 gives us 120, and then we set this up as a division problem. Working from left to right, 4 into 1 doesn't go, so 0 at the top, and we carry our 1. Now we have 4 into 12, and that goes 3 times, so 3 up the top. Finally, 4 into 0, it doesn't go, so 0 up the top, and we have our answer of 30. So 12 divided by 0.4 is 30. 0.35 divided by 14. In this example, our divisor, 14, is already a whole number, so we're just going to leave our numbers as they are, and just set this up as a division problem. 14 into 0 doesn't go, and we have nothing to carry, so 0 up the top, and move on to the next column. 14 into 3 doesn't go, 0 up the top, but we carry the 3. And now we have 14 into 35, because the 3 we carried and the 5 in this column. 14 goes into 35 twice, because 14 times 2 is 28. So that 2 goes up the top, and we have a remainder of 7, because 35 minus 28 is 7. And we carry this, and this gives us the problem of 14 into 70, which is exactly 5. So 5 on the top, and we have our answer of 0.025. Now we're going to use snowfall data that Walter found on his trip, and we're going to use that to learn about multiplication and decimals. 5 multiplied by 0.3. To make this easier, let's make our decimal a whole number like we were doing before. 0.3 multiplied by 10 giving us 3. Now we can do 5 multiplied by 3 equaling 15, and then we just divide that by the 10 that we multiplied with, and we get our final answer. So 15 divided by 10 equals 1.5, and that is the same as 5 multiplied by 0.3, just with an extra step to make decimals more easy to work with. This is the technique that we're going to be practicing. So calculate 12 multiplied by 0.3. As we just did, 0.3 multiplied by 10 is 3. Now we can multiply our 12 by 3. And then because we multiplied by a 10, we need to divide by a 10. 36 divided by 10 is 3.6, and we found the solution. 1.5 multiplied by 0.4. So this time we have 2 decimals, so let's multiply both of them by 10. Now we complete our multiplication. However, this time we multiply by 10 twice, so we need to divide by 10 twice. 60 divided by 10 is 6, and then 6 divided by 10 is 0.6, and there's our answer. Solve 0.15 multiplied by 0.7. However, there's something slightly different this time. 0.15 times 10 only gives us 1.5, which is still a decimal. So instead of multiplying by 10, we're going to multiply by 100. 0.15 multiplied by 100 gives us 15. And then 0.7 times 10 equals 7. So now we have the problem 15 multiplied by 7, which equals 105. We multiply by 100, and we multiply by 10. So now 105 divided by 100, so we bounce the decimal next to the 5 2 points to the left, and that gives us 1.05, and then dividing by the 10 that we used as well, 1.05 divided by 10 equals 0.105. So those are the basic techniques for addition, subtraction, division and multiplications involving decimals. As a bonus, if you get answers that involve repeating decimals, here's 2 ways that you can express them. So first, with a simple dot or even a set of dots to show a repeating pattern. Another method of notation is to use a line, and this line is called a vinculum. This is placed above the repeating region of the decimal. That's all for decimals and Walter for now, but we will see him again.